Hi, so I wanted to talk a little bit about the muscles, your skeletal muscles in particular, and the how your muscles actually function, how they contract. First of all, I wanted to, well, first we have to go over the anatomy of the muscles, um, so you understand at least a little bit about the components that make up the muscles, so you can understand how they work. But first, I want to draw your attention to this little picture I have up here. I have some Vienna sausages here, and I have here's the open can of Vienna sausages. I have some golf clubs and golf balls right here, and then I have a pearl necklace down here. And what does this have to do with muscles, you say? I know, but if you just keep these in the back of your mind, you'll be able to visualize how the muscles actually work a little bit better. So first I want to draw your attention to the Vienna sausages. We're all familiar with these if you've gone camping or just there's probably one in the back of your pantry. And here's a picture of it with it open. And you see when you open the can of Vienna sausages, these little Vienna sausages are lined up right here real nice and neat. So let's keep that in mind as we look at this next page right here. So here's the Vienna sausages and here's the skeletal muscle structure. Here's an arm right here. And here's your bicep muscle right here. And see how here's your shoulder bone right here, your clavicle and your scapula up here, and the tendon is connected to it. You see the little white tendon on the edge of the muscle, and then the muscle itself comes down, and here's the ending tendon where it's inserted into the arm here, the lower arm. So if we cut this muscle in half, right like this, just across length in half, then we can see over here, we can see what it looks like inside. Now here's the bone over here. Here's, you could say this is the shoulder bone, the clavicle or the scapula, or you can relate this to any other part of the body. This could be the tibia or this could be the femur or whatever. All the bones have, all of the bones that have muscles connected to them. So here's the bone, and here's the tendon connected to the bone, which connects the muscle to the bone. And here's the muscle coming off, just like right over here you see the tendon and the muscle coming off of the bone. And this muscle, this is just one muscle like the bicep. This muscle is surrounded, it's wrapped up in an outer layer called the epimysium. And epi means above, and the mysium is the membrane, the little wrapper that wraps around it. So it's above everything else, or it's superficial to everything else. It's on the outside. So that's the epimysium. Now, as I said, we cut this muscle in half, and so you can see here the way the muscle is cut in half, and it looks like a bunch of little Vienna sausages, like up here when you open the can, and there's these little round things, and those are actually sausages that go down in there like little tubes, right? So the same thing goes for this muscle. When you cut it in half, it looks like a bunch of Vienna sausages lined up like an opening of a can, and here we pulled one of these out. We pulled one of the sausages out, and you can kind of see it pulled out there. And this sausage is called a fascicle. And here's the word down here, fascicle. The muscle, if you cut the muscle open, it's going to be comprised of these big round tubes that are lined up together, just like the Vienna sausages. And each of those little tubes that you can pull out and look at, those are called fascicles. So a muscle, a whole muscle, like if this is the bicep or something, a muscle is a bundle of fascicles. See this? So this would be a bundle of fascicles, a whole bunch of fascicles wrapped, lined up in a little circle here with the outer layer wrapper called epimysium. So a muscle is a bundle of fascicles wrapped in the epimysium. Now, if you pull this fascicle out here, right here, then you can see this fascicle itself. If you cut this fascicle in half and look at it, this fascicle itself looks like a bunch of Vienna sausages when you cut it open like this, as you can see. And here's one of the little sausages pulled out right here. So one of these, when you cut open each fascicle, the fascicle itself looks like a bundle of Vienna sausages also. And the little sausage in here, each little Vienna sausage that's in the fascicle, are called fibers. And the fiber is the cellular level of the muscle. That's each fiber is one cell of the muscle. And the fascicle itself, the original Vienna sausages, the big ones, that make up the bundle of muscles, are also wrapped in a wrapper. The outer layer is called perimycium. Peri means around. So the mycium is wrapped around each individual fascicle, is the perimycium. And then within the perimycium, there's another bundle of Vienna sausages, and those little Vienna called fiber, muscle fiber. If you look at this up close, I just want to give you a better close-up picture of it. Here is the bicep of the arm, and here's the bone up here. See, here's right here is where the scapula ends, and then right here this bone going down here, up and down here. So that's the humerus, and coming off of where the humerus is connected to the scapula right here is a tendon, and it comes around and it comes down. And the other head of the bicep, because bicep, it has two heads, see, it wraps around and it goes in the front of and it connects to the clavicle in the front. So here's the bicep. You cut this in half, and here's what it looks like when you cut it in half. So here's the bone again. Here's the tendon coming off the bone to connect the muscle to the bone. And you cut this in half, and it looks like a bunch of Vienna sausages. And each Vienna sausage, each of these big tubes, are bundled together and wrapped in an outer layer called epimycium, this pink outer layer, epimycium. And each of these bundles, each of these Vienna sausages, are called fascicles. See, here's the word right here, fascicle. And the fascicles are each wrapped in perimycium. And then if you cut those fascicles open, a fascicle open, there's little tiny Vienna sausages within the fascicle. And those little tiny Vienna sausages within the fascicle are called fibers. And that's one cell of the muscle. Each fiber is one cell of the muscle. Now, when we get to the fiber, and here's fiber right here, a cell of a muscle, and each fiber is wrapped in endomycium. Endo means inside, and here's the word endomycium. Endo means inside, like indoor, and it's wrapped in endomycium. So again, the muscle itself is wrapped in epimycium. It's made of a bundle of fascicles. Each fascicle is wrapped in perimycium, and the fascicle is a bundle of fibers. And each individual fiber, or each cell, is wrapped in endomycium. So epimycium, perimycium, endomycium. Muscle, fascicles, fibers. Now I have back up here, just so you can remember, here's the picture, here's the fascicles, here's each of these are fibers. Here's a fiber, muscle fiber coming out of the fascicle. And let's look at this for a minute. This is one big fascicle right here. I'm zooming in to the fibers. So this is one fascicle that makes up the muscle, and then this fascicle is pulled out so you can see all the fibers. And so this is one fiber pulled out. This is a muscle fiber. And see, inside the fiber itself, if you cut that fiber open, it looks like another can of Vienna sausages that you just opened, but a whole bunch more Vienna sausages are in there. Do you see that? And each of those little Vienna sausages are called myofibrils. Myo for muscle, M-Y-O, Anytime you see the prefix MYO, that stands for muscle, myo, and then fibril. So fibril, a little tiny fiber. So you got the muscle. The muscle is a group of bundle of fascicles. The fascicle is a bundle of fibers, and the fiber itself is a bundle of myofibrils. And this is going to be important. This myofibrils, these are where the action happens on the myofibril level. Now the myofibril, if you pull that over or cut that in half, myofibrils, within the myofibrils it's made up of a bundle of myofilaments. And we'll get to the myofilaments in a minute, to what they are. But this is at the level, the myofibrils and the myofilaments. The myofilaments is when I want you to think of the golf clubs here and the pearl necklace, because there's two different kinds of myofilaments. There's the thick filament and the thin filament, and those are going to be related to golf clubs and pearl necklaces. So just keep that in the back of your mind. Now here's the myofilaments down here, and I know we skipped this up here where it says sarcomeres, but I'll go back to that at a later time. What you need to know is these myofilaments, these little individual little Vienna sausages, or these little strings, they're so small, that make up the myofibrils. There are ones that look like golf clubs, and here's the golf club down here, and there's the type that make up a pearl necklace that looks like it's twisted, and here it is right here. The golf clubs are called myosin. So once again, myo, M-Y-O, that means muscle, so myosin. And then the pearl necklace that looks like it's twisted in like a double helix shape is called actin. And those are these little pearls right here. Don't worry about this rope around the pearl necklace yet. Just look at these pearls, these orange pearls, and they're twisted up looking like a pearl necklace. That's called actin. Now here's what you need to know about the myosin and the actin. The myosin and the actin are where the action happens, pretty much. I always think actin, action, because that's where the action happens. So you have this pearl necklace, and it's actually a double pearl necklace, and it's all twisted together, just like it is up here. These orange balls, these orange pearl looking things. So let's just act like I drew a double helix of pearls, but I'm going to keep it like this just so you can see, so the picture is more clear. So here's the actin, these strings of pearls, this double string of pearls. And on each pearl, on each active site, or on each actin site, on each pearl, there is like a little handle. It's a little hole on the pearl, on the top of the pearl, and it's like if it was a box, it would be the little hole in the side of the box where you can put your hands, like a handle, so you can carry a box around. There's just these little indentions in each pearl in the actin, and these are called active sites. So there's little handles on here. But we can't do anything with little handles because there's this rope, and this is the rope I'm talking about up here. There's this rope that goes around, that twists around the string of pearls, and it covers up those active sites. It just blocks it physically. It just stands in front of it and just blocks these active sites, so nobody can get to the little holes or the little handles in the pearls. Okay? Now this rope is called tropomyosin. The tropomyosin wraps around the strand of pearls and it blocks these active sites. So it covers the active sites so you can't get to the holes. Now, and there's a reason why you want to get to the holes, and I'll tell you that in a minute. Now, on top of the tropomyosin, where it blocks these active sites, there's one more thing. Let's see. There is, at every active site that the tropomyosin is blocking, these little balls come, bounce, 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 and they sit on top of the tropomyosin. So they sit right on top of the tropomyosin over the active sites, over where the active sites are in the actin. They're like, you throwing a party? I want a party. I want to come. Can I come to the party? So they kind of invite themselves and bind to the tropomyosin, which is in turn bound to the actin, the active sites on the actin. Okay, so these are called troponin. So the troponin sits on the tropomyosin, which is covering the active sites of the actin. Now, here's a sort of a simplistic version of what I just drew, just so you can see better. See, now here is the actin down here. Here are the active sites on the actin. This is the tropomyosin, and here's the troponin sitting on top of the tropomyosin over where each actin active site is. Now, hovering above this is this other thing that I was talking about, this golf club. Hovering above this is a golf club. Okay, so we're going to draw the golf. This is kind of a poor golf club, but here's the golf club hovering above this strand of pearls, the actin, covered by the rope, the tropomyosin, covered by those little spheres, the troponin. And this golf club's hanging out up here. Now, why is a golf club hanging out up here? Well, because it has an important job to do. The only reason why it's hanging out up here is because the troponin is blocking the golf club from getting into the active site right here. See, these little holes that I was talking about, these handles in the actin, these are the perfect size and shape to fit this golf club head right here. Now so I don't keep calling it a golf club, this is called myosin. So this golf club, or this myosin, has this little golf club head on it, and it wants to sink down into these little holes, the actin active sites, these little handles. It fits perfectly in there. But it can't because it's being blocked by this troponin sitting on top of the tropomyosin, which is blocking those sites, right? Now what happens is, and this is how your muscle is when you're not using it, when it's just at rest. What happens is calcium comes into the cell, and I'll talk about how calcium gets in there later on, but just right now, just know that calcium comes down the street, it comes along. Calcium comes into the cell, and it's like, oh, hey, what's up, guys? How you doing? And calcium floats in, so there's a whole bunch of calcium down here, and it comes down, and it kicks the troponin away. Now what happens when it kicks the troponin away? The troponin is kind of glued to the tropomyosin, the rope right here. So when the troponin goes away, it pulls the tropomyosin with it. So what the calcium does is it floats into the cell. It comes in from somewhere else, and I'll get into that later. But the calcium comes into the cell, and it comes down, and it kicks this troponin away. Now when the troponin goes away, the troponin falls up here. Well, the troponin is stuck to this rope, this tropomyosin. So when the troponin gets kicked away like a kickball, it takes the rope with it. It takes this tropomyosin with it. So it comes off of the strand of pearls of the actin, and it moves out of the way. Well, when it moves out of the way, what can happen now? This myosin up here, this golf club head, can come down and stick itself into the actin active sites, because those little handles, those little holes in the strand of pearls in the actin are now exposed because the troponin and the tropomyosin got kicked away. So those are off. So now the myosin can come down here and put its little golf head in the holes in the actin active sites in the actin. Now, here's a more simplified picture here. So now that the actin active sites are exposed because the calcium kicked the kickball, the troponin, and the troponin was attached to the tropomyosin, so those all flew away. Those all got kicked away by the calcium. So now the myosin can bend down or fall down into these actin active sites, into these holes. And when it does that, it moves down. There you go, there's a little golf club. So the golf club moves down and puts the little head thing in the hole in the actin active site. So when that happens, what is also floating around in the cell and what comes along but ATP. And ATP starts floating down here. Now when the myosin sticks into the actin active site, it acts like a ratchet, which means it's normally shaped with its golf club head out like that a little bit, but then when it goes into the actin active site, it moves back the golf club head. So it moves back so it looks like this. So see how that moved back like that? It kind of just moves a little bit. But when it moves the strand of pearls, the actin site, with it. So when this happens over here, here's back to the picture of the purple myosin in the active site. When it moves back like this whole strand of pearls gets pulled this way like a tug of war. And it moves these back. And then the ATP, when it comes in here, the energy from the ATP gets the golf club to release itself from the strand of pearls, and then the strand of pearls snaps back to where it was originally, and that's when your muscle relaxes. So the contraction part of your muscle is just this myosin head pulling the actin towards it by making this little movement here. And then when the ATP comes in and gives the myosin energy, it releases the strand of pearls, the actin, and the actin snaps back to where it was before. That's your muscle relaxing.